All right, excuse me, continuing chapter 13, we are dealing with liquids. In 13.1, we are dealing with gases. In 13.2 and 13.3 today, we're going to deal with liquids, and then we'll wrap the chapter up with solids. So when we talk about liquids, we have a little bit of vocab information which we need to talk about how liquids interact with one another. First off, we have cohesive forces. And what are cohesive forces? The electromagnetic forces of attraction between particles of a fluid. So remember, when we talk about fluids, fluids take the shape of their container, similar to gases, and they have a little more cohesive force. And this cohesion force can result in a couple of things. And the first thing it can result in is surface tension. What is surface tension? It's the attraction of a liquid to underneath and sides of a container, but not the top, causing tension. So water has really, really great surface tension. You think about it, you drop a drop of water down, what happens? That drop is going to stick there practically. It is going to stay on the table. It's not going to spread out or fan out. If we did that with something like acetone or an alcohol, it's not going to do that because alcohol does not have as good a surface tension as water does. So this tension makes it create its shape. Also, we have viscosity. Viscosity is just the resistance to flow. So since it's stinking cold outside right now, all right, you've all heard the phrase as slow as molasses in January. Molasses has very high viscosity because it has a resistance to flow. Molasses is not going to flow very quickly down a hill as in comparison to a fluid that flows quickly like water. Water has a pretty good viscosity, or oil has a very low viscosity. So those things are caused by cohesion forces. Then we have something called adhesive forces. Now adhesive, when you think of adhesive, you may think of glue or sticking to, and that's kind of what happens. When we talk about adhesive forces, again, we're dealing with electromagnetic forces that act between particles of two different substances. So two different substances sticking together. That is adhesive forces. This is capillary action. Some of you gave blood yesterday in the blood drive, and what you noticed was sometimes, if you've ever pricked your finger with blood, they'll take a small glass tube and they put it right over that. And what will happen is the blood will seemingly climb that tube. What's happening is the blood has an adhesive force to the sides of the tube and kind of keeps climbing up. So that is capillary action, the movement of liquid in a small tube. And this should be review from chemistry because we've talked about surface tension, viscosity, and capillary action. All right, a couple things to finish up. Excuse me, when we talk about liquids. Liquids undergo really two phase changes. They can go from a liquid to a gas or a liquid to a solid. And when that occurs, or actually this is a liquid to a gas, gas to a liquid, but what we have is evaporation. Evaporation is a cooling process. Why do you sweat? What happens to your sweat? It evaporates off your body. It's your body's natural process of cooling yourself down when we go from a liquid to a gas. Why do you feel hot on hot, muggy days? Because the water it's less capable of evaporating. So the evaporation is occurring at a slower rate. Therefore, your body does not cool down as quickly on warm days as it does in the dry days of winter. If something is to evaporate very quickly, it is called volatile. Volatile is just the word that we use for that. What is an example of something that's volatile? Gasoline technically evaporates very quickly. Acetone. A lot of our alcohols also evaporate quickly. So I went on to explain why do humid days feel warmer than drier days, and that has to do with evaporation. Your skin, there's more water that's able to go into the atmosphere on a dry day than a humid day, so that is how it works. That's why you feel warmer. Condensation, the exact opposite of evaporation. We're going from a gas to a liquid. We're losing kinetic energy. What's an example of this? Fog. Fog usually forms when moist air is chilled by the cool ground. When does fog happen a lot? Early in the springtime. You have a lot of water vapor in the air from melting snow, but at the same time, that snowpack is very cold and you create fog, very, very heavy fog in March and April. So just a kind of a key example of what condensation is. So when we talk about liquids, here are a few examples of interactions we have with liquids.